Welcome to Maths for All. I'm Aisling Flynn. This is the line 1.5, intersecting lines. Intersecting lines. The word intersect means to cross over, okay, like two roads intersect at a junction. Where two lines intersect, they have the same x and y value at that point. I.e., the values of x and y are simultaneous, so they are the same at the same time or place for the two lines. So we can find the point of intersection of two lines by using simultaneous equations. So using the equations of the two lines together, we can find the point where the x and the y values are the same. That gives the point of intersection. So we're going to see how we might do that with the following question. So L is the line x minus 2y plus 2 equals 0, and M is the line 3x plus y minus 8 equals 0. Use simultaneous equations to find the coordinates of P, the point of intersection of L and M. So we're specifically told in this question to use simultaneous equations. You may not always be instructed to do that. So we're going to start with line L and make some adjustments. So if you look up to the top here, we've made a little arrangement. We've taken 2 from both sides, and now it looks like this here. Okay, x minus 2y equals minus 2, and we're used to using this format for simultaneous equations. You might look back through your algebra lessons to remind yourself of this. And then we're going to take line M from up here, and we're going to multiply that by 2. So 3x becomes 6x plus y becomes 2y, and at the same time you'd have minus 16. If you take minus 16 from both sides, you get plus 16 over here. So we've moved the number to the right hand side here as well. Okay, so a bit of groundwork to do there. Now we're going to combine these equations, or use them simultaneously at the same time. Okay, so what do we get when we combine the two equations? Well, minus 2y and plus 2y gives 0. That's why we use this method. And together the x's, x and 6x made 7x, and then on the left, and the numbers make plus 14 on the right. Okay, so now we only have one variable to work with, and we can solve for x. So divide both sides by 7. We get 1x equals to 14 over 7. So x is equal to 2. Alright, and use that value then with either of your equations above. I've used this version of L. And instead of x now, you're going to put in 2. So 2 minus 2y equals minus 2. Okay, so some moving around. What I did there actually was I put the y's on the right hand side and took the numbers from the left. Okay, and I get 2y equals 4. Just reading it from right to left, and divide both sides by 2, you get y equals 2. Okay, now to check if you're right, what you can do is you can put these values into both the lines L and M. So if we take L, it was x, which is 2, minus 2 times y, which is 2, plus 2 equals 0. So you get 2 minus 4 plus 2 equals 0, which will be 4 minus 4 equals 0. That's right. So it works for L, those combination of numbers. You can check for M also. 3 times 2 plus 2 minus 8, is it equal to 0? You get 6 plus 2 minus 8 equals 0. 8 8 minus 8 gives 0. So yeah, so this combination of numbers works simultaneously. So at the same time it works for line L and for line M. It makes both of them true. It means that the point xy, which is 2, 2, or the point of intersection, belongs to line L but also to line M. So it must be the point at which they cross over. And let's look at that now on a graph. So let's show line L first. Okay, there we have that, that's line L, and line M is there. And we can see that the point of intersection is here, which is 2, 2. So a graphical method of finding the point of intersection would be to plot each line. Okay, for that you need either 2 points or you need the slope and the y-intercept. Okay, and we found 2, 2 is the point of intersection. So here's another question. Find the point of intersection of the two lines y equals 3x minus 2 and y equals minus x plus 1. Now in this particular question we're presented with the equations of the line in this form, y equals mx plus c, and often this is very much easier to work with. At the point of intersection the y value for each line is equal. So they both have the same y value, and for that reason we're going to equate, which means to put equal the y values from each. So let's call 3x minus 2 is line A and minus x plus 1 is line B, and we're going to equate ya equals to yb. So for line A, y is 3x minus 2, and for line B, y is minus x plus 1. So put them equal to each other. And what we get as a result of that is a very straightforward equation with only one variable, which is x, to solve for. So that's what we're going to do now. We're first going to gather the x's to one side and the numbers to the other by, let's remove the x from the right hand side. That means we need to add x to both sides. And we're going to remove this minus 2 from the left hand side. Means we have to add 2 to both sides, and we get the following line as a result. Let's simplify that. 3x plus x gives 4x and 1 plus 2 gives 3, and the last step to solve for x is to divide both sides by 4, and we get x equals 3 over 4, or 3/4. Okay, so we're half the way there. Now we need to use the equation of one of the lines. I chose line B to find y. So this is line B. I chose it because we don't have to multiply the x. Okay, so y equals minus x. So instead of x we're now writing 3/4, 3 over 4 plus 1, and minus 3/4 plus 1 gives me plus 1/4. So there I have a y value, and now we have the point of intersection as being 3/4, 1/4. So let's look at what that looks like on a graph. So if you're to do it by drawing, by graphical methods, here we have, this is line B. Okay, this is line B. You can see it has a slope of minus 1. If you do rise over run, there's the rises. If you drop 1, go over 1. So it's minus 1 is to 1. You have a slope of minus 1, and you have a y-intercept of plus 1 there. So that's line B. Line A has a y-intercept of minus 2, which is here, and it has a slope of 3. So if you run 1, it climbs 3. Okay, 1 is to 3 there. And we can see where the two lines cross over. Now by graphical methods we'd probably be estimating. It's not as accurate as algebra. Alright, but you can compare there and you can see, yeah, we can see that that probably is 3/4 on the x axis, so not quite up as far as 1, and 1/4 on the y axis. And that's our point of intersection. Now you try some work on that with the quiz and the written exercises.